Hi and hello. Hi and hello. Welcome to the lecture series of wireless communication. Now we are discussing about the free space propagation model, in which the link budget design is very important concept. Okay, so we have seen in the last class about what is negative link margin. That means you have, if the receiver has to be replaced, if you have negative link margin, that means we have to improve your sensitivity under the receiving antenna also. Okay, when design a complete that is an end-to-end radio communication system, it is necessary to calculate what is termed the link budget. The link budget enables factors such as the required antenna gain levels, the radio transmitted power levels, and the receiver sensitivity figures to be determined. Okay, so the link budget is most important while designing any type of antenna or any type of communication model. So this link budget will covers all this while designing a complete propagation model, that is a communication model. This link budget you have to be considered, such as the antenna gain level, the radio transmitted power levels, and the receiver sensitivities. So with these values only you can able to address that this particular mobile radio channel is good or bad. So by assessing the link budget, it is possible to design a system so that it meets its requirement and perform correctly without being over designed at extra cost. Okay, so as a designer you have to be considered a lot of factors. So that's why we have such a complex task whenever you design a mobile radio communication systems. Okay, so this link budget design is similarly, you have to be careful, and it should meet its requirements and should not be any extra cost should be avoided. Okay, then what is link budget? As the name implies, the link budget is an accounting of all the gains and losses in the transmission system. Okay, whatever the business we are doing, we have to calculate what is the investment I have did. Similarly, what is the gain, that is how much I earned by this business. So only with the help of these two things you can identify whether the system is working properly, whether your business is going properly or not. Similarly, a link budget is accounting all the gains and losses in the transmission system. So there is very important thing whenever designing a transmission system. So without this link budget, if you design the line system, then you will not meet any requirements of the designers. Okay, in essence, the link budget will take the form of equation below, that is, the received power in the terms of dB will be equal to transmitted power plus gain minus losses. How much losses you have, that will be neglected from your transmitting power plus gain value. Okay, where the losses may vary with time, that is, it's a time variable parameter, that is, example, fading and allowance must be made within the link budget. For this, often the worst case may be taken, or alternatively an acceptance of periods of increased bit rate error or degraded signal to noise ratio for analog system. Next, the link budget equation. In order to devise a link budget equation, it is necessary to investigate all the areas where gains and losses may occur between the transmitter and receiver. Although the guidelines and suggestions can be made regarding the possible areas for losses and gains, each link has to be analyzed on its own merits. Okay, so the link budget equation should be designed so it is necessary to all the areas, because you are going to calculate all the gains which is received by your transmission system through antennas, and also what are the losses because of you have lose some weak signal, because of this weakness of the signal strength you will be lose some informations that also has been accountable. Although the guidelines suggestion can be made that regarding possible areas for losses we think to be analyzed on own merit only. So individually the particular area, with the particular area you have to calculate the loss and gains, and you have to be link with each one, and finally you have to analyze the consolidated things. Okay, now the typical link budget equation for radio communication system may look like the following: P or X, that is a receiver power equal to transmitter power plus transmitter gain plus receiver gain minus loss of transmitter minus LFS minus LP minus RX. What if LTX, LFS, LP and LRX is nothing but losses. So that is transmitter feeder and associated losses. That is LTX. Okay, LFS means free space or path loss during the transmission between the transmitter and receiver. Then what is LP? Means some signal propagation losses because of fading, then mismatching, and the losses of during the traveling time you will be getting this LP. Then LRX is the receiver feeder and associated losses. That is receiver feeder, receiver connectors we have counted. Because of the loss, we will be having some losses. So all the losses will be 4 losses will be neglected from the your transmitted power addition of gain of both transmitter and receiver.